Gyroscopic transport. Let's begin with a concept that solves a fundamental urban problem: the inefficiency of the single-occupant car. Gyroscopic transport proposes a network of lightweight, elevated guideways, but instead of large train carriages, it uses small, personal pods. The engineering marvel here is the gyroscope. Inside each pod, a high-speed, electrically driven flywheel spins, creating immense stabilizing force. This gyroscopic effect allows the pod to remain perfectly balanced and upright on a single, narrow rail, even during sharp turns or when stopped. Imagine a system where you use an app to summon a pod that picks you up and takes you directly to your office doorstep, non-stop, while gliding silently above the traffic. It's a form of personal rapid transit that offers the privacy and point-to-point convenience of a car, but with the space-saving and energy efficiency of public transport, potentially rendering traffic jams and the search for parking a relic of the past. Renault Float. Moving from engineering to pure philosophy, we have the Renault Float. This is less a car and more a social bubble, a vision for the year 2040. Its most striking feature is its spherical, transparent design, allowing for 360-degree views, and its method of movement, magnetic levitation. It floats silently above the ground, creating an almost magical, dreamlike travel experience. There is no steering wheel. And artificial intelligence handles navigation entirely. But the true genius of the float is its focus on human connection. The pods are designed to be social catalysts. Using a combination of magnetism and robotics, two or more floats can physically connect, merging their interiors to form a shared social space. Your commute could become a mobile cafe meeting, or a chance to spontaneously connect with a friend heading in the same direction. The Renault Float asks a profound question: in a fully autonomous future, shouldn't our vehicles enhance our humanity and our relationships, rather than isolate us? Flying train. The concept of a flying train is perhaps the ultimate fusion of ground and air travel technologies. This isn't a plane, and it's not a conventional train. The concept involves a maglev vehicle, similar to those already in use in Japan and China, but instead of running on an open track, it operates inside a long, sealed tube. This tube is then depressurized to create a partial vacuum, removing nearly all of the air resistance, the primary barrier to high-speed ground travel. By levitating magnetically and encountering no air drag, the flying train could achieve sustained speeds of over 1,000 kilometers per hour, rivaling commercial aircraft. It would offer the frequency and city center to city center convenience of a train, with the speed of a jet, all while being powered entirely by electricity. It represents the pinnacle of fixed guideway travel, a potential successor to both short-haul flights and conventional high-speed rail. MG Maze concept car. As we transition to self-driving cars, a critical question emerges: what do we do with all that freed up time? The MG Maze concept car provides a radical and exciting answer: we play. This autonomous electric vehicle is conceived as a multisensory gaming platform on wheels. Its interior is a minimalist, reconfigurable lounge. The windows are not just for viewing the outside world, they are augmented reality screens that can overlay digital game elements onto the real landscape. More impressively, the car's driving systems, its steering, acceleration, and braking, can be synced with a game. Imagine racing through a virtual world, and feeling every turn and burst of speed physically as the car gently replicates the movements. The MG Maze posits that the future of travel isn't just about efficiency. For many, it will be about entertainment, escapism, and turning dead travel time into an adventure. SkyWay technology advantages. While many concepts are glamorous, the SkyWay system, also known as string transport, stands out for its pragmatic and holistic approach to solving traffic congestion. Its advantages are multi-layered. First, economic efficiency. The elevated rail structures, supported by lightweight strings or cables, require far less concrete and steel than subways or traditional railways, slashing construction costs by up to 50 to 70%. Second, environmental and spatial intelligence. The narrow support pillars have a minimal footprint, allowing the network to be built over existing roads, railways, or even sensitive ecological areas without major disruption. The guideways themselves can be fitted with solar panels, making the system energy independent. Third, operational flexibility. Unlike heavy metro systems, SkyWay's small, automated pods can run on demand, 24/7, eliminating wait times and unnecessary stops. It's a system designed not just for rich nations, but as a scalable, affordable solution for megacities worldwide. Airspace Cabin Vision 2035 Plus. Airbus's Airspace Cabin Vision 2035 Plus looks beyond the metal fuselage to reimagine the very experience of flight. This is a human-centric design philosophy that turns the cabin from a passive tube into an adaptive, healing environment. It leverages biometrics and AI. As you board, sensors could discreetly check your vital signs and adjust your personal space, the lighting, temperature, and even seat firmness to help align with your circadian rhythm and reduce jet lag. The traditional window could be replaced by a full-length, programmable display, offering a panoramic view of the sky, a live feed from a bottom-facing camera, or a calming, immersive art piece. The cabin layout is fluid, with zones that can be reconfigured in flight, a vibrant social hub for networking, a quiet wellness area for yoga or meditation, and a proper rest zone with lie-flat beds for all passengers. It's a vision where you arrive at your destination feeling better than when you left. EHang 216. The EHang 216 is the workhorse of the urban air mobility (UAM) revolution, and it's already a tangible reality. This two-passenger, fully autonomous aerial vehicle is what happens when you scale up drone technology to human carrying capacity. Its design, with 16 independent rotors, 8 on top, 8 on bottom, provides critical redundancy. If one or even several motors fail, the others can compensate to ensure a safe landing. The flight is entirely pre-programmed and automated. You simply select your destination on a touchscreen map and the vehicle does the rest, communicating with a central command and control network to ensure safe routing. With a range of around 35 kilometers, it's perfect for airport shuttles, city tourism, or emergency response, offering a bird's-eye view solution to the most congested ground routes and proving that the age of the passenger drone is not coming, it's already here. Virgin Hyperloop. The Virgin Hyperloop is arguably the most ambitious terrestrial transport concept of the 21st century. It aims to create a brand new mode of transport that is faster than high-speed rail, more efficient than trucks, and cleaner than aircraft. The core principles are physics-based elegance. By placing magnetically levitating pods inside a low-pressure steel tube, you eliminate the two main enemies of speed, friction and air resistance. The pods, propelled by linear electric motors, could glide at near supersonic speeds using a fraction of the energy of a plane. A trip from Mumbai to Pune could be cut from over 3 hours to just 25 minutes. Beyond speed, the system is designed to be weatherproof, direct, and capable of being powered entirely by renewable energy. While the challenges, safety certification, infrastructure cost, and regulatory frameworks are monumental, the Hyperloop represents a fundamental paradigm shift, a moonshot for ground transportation. Bellwether eVTOL. The Bellwether eVTOL represents the air taxi segment of the urban air mobility market. Unlike the multicopter-style EHang, many eVTOLs like those envisioned by Bellwether often feature a lift plus cruise design. They have multiple rotors for vertical takeoff and landing, but once airborne, they transition to forward flight using a fixed wing and a pusher propeller, much like a small plane. This is a crucial distinction for efficiency. It allows for greater speeds and a much longer range, potentially connecting city centers with distant suburbs or even making intercity flights of 100 to 200 kilometers feasible. These vehicles are initially being designed with a pilot in mind to streamline regulatory approval, but are built for eventual autonomy. They promise a quiet, zero-emission, and point-to-point alternative to helicopters in short-haul flights, effectively creating a new layer of three-dimensional mobility in our skies. Avant Solo Electric Sport Car. In a future dominated by autonomous pods and shared mobility, the Avant Solo Electric Sport Car makes a passionate case for the preservation of the driving experience. This vehicle is a love letter to the art of driving, supercharged by electric technology. It leverages the inherent advantages of an EV: instant torque, a low center of gravity from its floor-mounted battery, and perfect weight distribution to deliver hyper-responsive and exhilarating performance. But it goes beyond raw acceleration. The chassis is tuned for tactile feedback, the steering is designed to be communicative, and the cockpit is a driver-centric sanctuary, putting the human in complete, joyful control. The Avant Solo argues that driving, in its purest form, is not a chore to be automated, but a skill and a pleasure to be cherished, a form of active entertainment and personal expression that will always have a place in our mobile world.